Okay, as I like to clean up the table and I have made such a nice picture, I wanted to first make some introduction about containers in C++ standard library and explain things characteristic for that, such as past the end, and also explain why the reverse iterator points to different element than the source forward iterator from which it has been taken. So here we have an example container. It doesn't really matter what type of container it is. We have 6 elements here, and we can take the beginning and the end of the iterator so that we can embrace the whole container, and we can move throughout the whole container, you're reaching every element. Now, what's important about iterators in C++ standard library is that every iterator has two characteristics and plays actually two roles, which are represented by these two arrows. The main role, which is represented by this arrow, is pointing to a particular element. Through this, we can access the element at which currently the iterator is set. The other is used for ranges. Range is some fragment of a container which embraces several number of them. Now, we can have here the beginning of the container. The beginning of the container always points to the first element of the container. Now, what we get from end is this so-called past the end value. Past the end means that it actually doesn't point to an element. You can see that this arrow points to something that might be an element, but it's not an element, and it's not allowed to extract the value. It's not allowed to dereference the iterator, that is because it doesn't point to any element. But this value still makes it sense, because it still has this second role, which is defining the ranges. So we can have also some iterator that points to some of these elements here. This element is some element inside the container, and when we try to access it, we access this element which it points. But if we want to have a range of element, then if we define it from this begin to x, then always these ranges are defined with the limits, because limits must be between the elements, as we want to embrace elements. So the range between begin and end is from here to here, because this second arrow defines the limit for the range. Now, with this range, we have these three elements. So this is the range from begin to x. To x means that the x itself is not included, because the limit is before the pointed element, always. That's why, if we want to embrace the whole container, we need something that is called past the end, because if we pointed to this element, last element, we'd have then the limit here, and we wouldn't be able to embrace this last element. Because of that, we are using this value, which is called past the end. Now, What happens if we want to move two elements in a reverse order? Several containers, at least the containers that belong to the category of a reversible container, that is simply when it is possible to walk to the previous element towards the pointed one. Several containers offer random access to elements. Several containers can only make the iterator point to the next element towards the existing elements, and some containers allow to select an iterator that points to a previous element towards this. So if we have this one, we can have a previous element from this, which is this one. So when a container offers such a possibility, then it is possible to reverse the container, not just invert elements, but use this inverted container with the algorithm that normally work only as forward. All algorithms that work as forward usually work this way. So if we want to walk through the elements from the first to the last one, then we have, for example, the for each, the simplest possible algorithm, which performs an operation on every element one after another. If we want to perform this in the reverse order, we can simply give this algorithm a range, which is a reversed range. Reversed range is simply using the methods called rBegin and rEnd. And how do these iterators look like? So the rBegin points to the exactly last element, while rEnd points to a past the end, or we can rather call it before the begin, because it's also pointing to an element that does not point to an element. This iterator does not point to an element. You can cross it out, right? But this pointing to a range is still meaningful. So if we take from rBegin to rEnd, we still embrace the whole container. Now, what happens for the iterator? Because of course, iterator has its own type, and the reversed iterator has also its distinct type. So they can't be used together. If we want to have an iterator pointing to an element but from the reverse perspective, if we want to have the range, inverted range, that is from rBegin to some x, the same x, for example, which is here, then we can get the reversed iterator from it. But somehow this iterator, when we get it, does not point to the same element here. It points to here. If we try to read the element, access the element through the iterator, if we try with this element, then it will access this element. If we make a reverse iterator basing on x iterator, it points to this element. And if we try to access the element through this iterator, we can see that we are accessing a different element. Why is that? This is because, as you can see, the range from begin to end is still from here to here. If we take the range from rBegin to rEnd, this is still from here to here. In both cases, we have the range of the whole container. If we do the same with, say, from some pointed x inside the container to end, we have these three elements. But if we take the range from rBegin to this reversed x, then we have, well, we have this, this, and this. Just like we have here. We have exactly the same range. We are just taking it from different different say different container, because it's from the different perspectives, I'd say so. But this x and this reverse x still points to the same border between elements, right? And because of that, all these elements that are embraced by this range represent the same range. So this is more or less how it's best to understand how the iterators in C++ standard library should work. And just you need to remember that in order to define ranges, this is the same thing in the normal life. If you want to define the ranges, you need to be clear about including elements that you use to describe the end or beginning of the range. Well, it's usually not a problem with the beginning of the range, and the element is usually included, but it's always a problem to define whether the ending element is included or not. So in C++ standard library, this is very simple. The first element, the element pointed by the beginning of the range, is included always. The element which is pointed by the end of range is never included. Because of that, we have also clear statement, for example, that if we have a range from two iterators that are equal to each other, we have an empty range. That's why it's very easy to declare an empty range, and it's very easy also to blindly try to perform an algorithm on the range of elements, no matter whether this is empty or not checking if this is empty or not. This internal loop, which is usually inside the algorithm, will just do nothing. I think it should be all. Thank you for watching.